alaikum. Hello everybody. This is an exercise about adjacent sequences. So let us consider un equal to 2 power n sine theta over 2 power n and vn equal to 2 power n tangent theta over 2 power n for n greater than or equal to 1, and theta belongs to the open interval 0 pi over 2. So first of all, we have cosine theta over 2n. Since theta belongs to 0 pi over 2, this is strictly less than 1 and greater than 0. This implies that 1 over cosine theta over 2n is strictly greater than 1. Very important, this first remark. Thus, since 1 is less than 1 over cosine theta over 2 power n, this gives us that sine theta over 2 power n is less sine theta over 2 power n divided by cosine theta 2 power n. This is tangent theta 2 power n. If we times by 2 power n, we get 2 power n sine theta divided by 2 power n. This is less than 2 power n tangent theta divided by 2 power n. This is un and this is vn. This is true for all n belongs to n, and theta between 0 and pi over 2. This is the first remark. The second remark, we will prove that un is an increasing or non-decreasing sequence, and vn is a decreasing or non-increasing sequence to get adjacent sequences. We will start by un. un plus 1 over un. Why I use the ratio instead the difference? Because our sequence is a multiplicative form and it is for all n it is a positive. So we will use this technique, and we compare this fraction with 1. Actually, this is equal to 2 power n plus 1 sine theta divided by 2 power n plus 1 divided by 2 power n sine theta over 2n, which is equal to 2 sine theta divided by 2 power n plus 1 divided by sine theta 2 power n, which is equal to 2 sine theta divided by 2 power n plus 1, and this one is equal to sine 1 over 2 times 2 times theta divided by 2n plus 1. So if we cancel 2 with 1, we will get our result here. The last one has from a previous result in mathematics, in trigonometry, sine x plus y, this is equal to sine x cosine y plus cosine x sine y. Sine x plus x, this is equal to 2 sine x cosine x. In this case we have sine theta divided by 2 power n plus 1 plus theta 2 plus 1, which is equal to 2 sine theta to n plus 1 cosine theta to n plus 1. If we replace this in this formula, we will obtain that un plus 1 over un is equal, we cancel 2 sine theta over 2 power n plus 1 with 2 sine theta, so we will get 1 divided by cosine theta divided by, which is greater than 1, and as we show previously. This means that un plus 1 is greater than un for n in n. And this interpretation means that un is increasing. Now we deal with Vn. For the same reason, we observe that Vn is a multiplicative sequences, so we think to use the technique Vn plus 1 over Vn, and we compare with 1. This is equal to n plus 1 tangent theta divided by 2n plus 1 divided by 2 power n tangent theta divided by 2n, which is equal to tangent 2 tangent theta divided by 2n plus 1 divided by tangent theta divided by 2 power n. Actually, we use the same technique as sine theta over 2n plus 1 twice. And this is equal to 2 tangent theta divided, here we have tangent theta divided by 2n plus 1 plus theta divided by 2n plus 1 twice. We use the same technique, basic information. We can write tangent as sine over cosine. We take cosine square as a common factor, and we will get we will get equal to 1 minus tangent square theta divided by 2n plus 1. Basic transformation, exactly like this transformation, basic. And this is less than 1, which means that this means that Vn is less than Vn plus 1 is less than Vn, so Vn is decreasing. The third point, Un is increasing and upper bounded by Vn, for example, by the element Vn. Why this is true? Because Vn is less than, because Un is less than Vn for all n greater or equal 1. We proved this previously. Un is increasing and upper bounded by Vn, so convergent. Vn is decreasing and lower bounded by Un for the same reason, then Vn is convergent. I need these informations to finish, to end the solution. The last point is to prove that the limit of Vn minus Un is equal to 0, 1, and goes to plus infinity. Actually, this is obvious. Why? Because Vn is equal to Un. Vn is equal to Un times 1 over cosine theta over 2n. Since we know from these two steps that Vn converge and Un converge, so this converge to a limit, let us say L1, and this converge to limit L2, but this one converge to 1 when n goes to plus infinity. This means that they have to converge to the same limit. Vn converge to L and Un converge to L, the same limit. This implies that the difference, the limit of the difference, is equal to 0. This is using a theorem of basic operation, algebraic operation on convergent sequences. We use this. Another way, we can consider the difference and take off Un and say that since Un is convergent, so it converges to a finite limit, the difference goes to 1 minus 1, which is equal to 0, so the difference is equal to 0. This ends this first exercise. The next exercise will be in independent video, will be about the two sequences. Un is equal to 1 plus 1 over n power n, and Vn is equal to 1 plus 1 over n power n plus 1. And we have to prove that they are adjacent. See you next video.